Today we'll be talking about rational expression. By rational expression, what we mean is fraction. But in this instance, we are including algebra. So if I have 2 over x, x minus 2 over x plus 3, and so forth. This is what we mean by rational expression. So the first thing that we're going to do would be, I know you have seen this, any number which ends up with the denominator 0 is undefined, any rational expression. So the first thing that we're going to ask ourselves is, suppose we have 2 over x, and then we are asked to find the domain. For what value of x are we not allowed in the denominator? So meaning what? X cannot equal to 0. If x is equal to 0, then it becomes undefined. So what we will be writing is the domain of 2 over x is negative infinity between 0 union 0 to infinity, meaning what? We take 0 out. If we have 0, then it becomes undefined. If we go and look at the second one, just only look at the denominator. Set the denominator x plus 3 is equal to 0, which gives us x is equal to negative 3, meaning if we plug x is equal to negative 3, the second rational expression becomes undefined because the denominator becomes 0. So therefore, you would write the domain to be negative infinity to negative 3 union negative 3 to infinity. This tells me what we are allowed to use in our expressions between negative infinity to negative 3 and between negative 3 and infinity. Okay. So, this is what we mean by domain. Suppose now let's say x over x squared minus 1, and then now we are asked to find the domain. Again, look at the denominator. Don't worry about the numerator. So set the denominator equal to 0 so that you know which values are we not allowed to plug in into the denominator. This is the difference of two squares. X squared minus 1 means x minus 1 times x plus 1 is equal to 0. If you go ahead and if x minus 1 is equal to 0, implies x is equal to 1. Meaning what? If I plug 1 into x, I would end up with a 0. So that means x cannot equal to 1. The same applies for the second one, x plus 1 is equal to 0. It implies x is equal to negative 1. And if you square negative 1, you would end up with 1. 1 minus 1 is equal to 0. Then x cannot also equal to negative 1. So we have two restrictions for this particular rational expressions. So now, how do we write the domain? Mind you, it is from negative infinity to infinity. That is the real number. So the domain will be, I start from negative infinity, and all values of x between negative infinity and negative 1, we are allowed to use that. But negative 1, right? And then you put a union. Then all values of x between negative 1 and 1 also we are allowed to use. Okay. Then you have from 1 to infinity. So this is the domain. Mind you, the borders, negative 1, negative 1, 1, 1. These are the only values that we are not allowed to use in this rational expression. Okay? So that's what we mean finding the domain. Always look at the denominator. See which number gives you a 0, and that's the one that you are going to exclude from the domain. Okay? Now, simplifying. Simplifying rational expression. Suppose you have x cubed plus x squared over x plus 1. Again, x cannot equal to negative 1. Okay. This time we're not writing the domain, but if we just only write x is not equal to negative 1, that will take care of itself. Then let's try to simplify this. The greatest common factor between x squared and x cubed is x squared. And you take out x plus 1. Okay. And then you have x plus 1 in the denominator. Now you can see x plus 1 and x plus 1 both in the numerator and in the denominator. Then you can cancel that. So your answer would be what? X squared, put a comma, x cannot equal to negative 1. You can draw the graph of this, but at x is equal to negative 1, there is an interruption. Okay? All right. Simplifying, we can also use that by multiplying rational expressions. So let's do multiplication. Again, it's the same concept as simplifying, but we have. So you have x minus 7 over x minus 1 times x squared minus 1 over 3x minus 21. Suppose you are asked to simplify this. Don't go ahead and multiply because you're going to end up with a complicated expression. So first what we need to do is let's factor, if we can factor in one. This one is prime, so I'm going to bring it down, x minus 7 over x minus 1. But this is the difference of two squares, so I can write this x squared minus 1 as a product of x plus 1 and x minus 1. Okay. Now I have 3x minus 21. I can find the greatest common factor, which is 3, and I end up with x minus 7. It would be wise at this juncture to put a note for yourself before you simplify. X cannot equal to 1 and x cannot equal to 7 for obvious reasons, because if you plug either one of them, you end up with a denominator 0. Then you go ahead and take x minus 1 out, x minus 7 out, then you end up with x plus 1 over 3 with a restriction, x cannot equal to 1 and x cannot equal to 7. Mind you, even though we simplify, we got rid of x minus 1 and x minus 7, still the expression tells me whatever you do, you cannot put x is equal to 1 and x is equal to 7. Okay? All right. I'm moving fast because we are doing this as a review, but if you have any questions, we can always do zoom in. And now let me do division. Suppose you have x squared minus 2x minus 8 over x squared minus 9 divided by x minus 4 over x plus 3. Okay. Before we do anything, change this into multiplication. Changing this into multiplication means we write the reciprocal of the second expression. So I'm going to rewrite this x squared minus 2x minus 8 over x squared minus 9 times x plus 3 over x minus 4. Okay, so we change it into multiplication. Now we are going to factor x squared minus 2x minus 8. two numbers multiplied will give us negative 8, and added will give us negative 2. This is x minus 4 and x plus 2. Okay, you do the product, the sum, and you will end up with this. The one in the denominator, x squared minus 9, is the difference of two squares. And so I can write this as x minus 3 and x plus 3. Now bring down x plus 3 and x minus 4. As I have told earlier, make sure x cannot equal to 3, x cannot equal to negative 3, and x cannot equal to 4. Okay? Now you can go ahead, simplify. X plus 3 and x plus 3 cancels out. X minus 4 and x minus 4 cancels out. So you end up with x plus 2 over x minus 3. So that's basically what we mean by dividing rational expressions. Okay. Now let's move on . Adding and subtracting the rational expressions. I want you to look at this one. You have 5x plus 1 over x squared minus 9 x squared minus 4x minus 2 over x squared minus 9. X squared minus 9. Okay. Now, since we have the same denominator, I can write this as one rational expression as opposed to two rational expressions. So I'm going to rewrite this x squared minus 9 at the bottom. Then I have 5x plus 1 minus, make sure to put a parenthesis because the negative sign is distributed. You are subtracting the entire thing from this one. So let me go ahead and do this. 5x minus 4x is x, right? And 1 minus negative 2 is 1 plus 2, which is x plus 3, over x squared minus 9 is x plus 3, x minus 3, right? Then you go ahead and simplify, so you end up with what? 1 over x minus 3. So if you have the same denominator, all you need to do is what? Simplify the one on top or the one in the numerator. Okay? And let me do another one. Oh, make sure to write the restrictions. I forgot to write that one, but I'll show you. It's not a big deal. X over x plus 1 minus 3x plus 2 over x plus 1. X cannot equal to negative 1. Okay? Bring together x plus 1. Then you have x minus, make sure to put a parenthesis because you can make a common error in writing the signs. X cannot equal to negative 1. So you go ahead, x minus 3x is minus 2x. Minus times plus is minus. So it becomes minus 2. minus 2x minus 2 because there is a negative 1 always in here. Input x plus 1 in which x cannot equal to negative 1. Okay. Then you can take this out. Take negative 2 as the greatest common factor. So you would end up with x plus 1 over x plus 1. So the x plus 1 and the x plus 1, x is equal to negative 2. So you end up with having negative 2 and x cannot equal to negative 1. Okay. Now the next one we'll be doing is what if we don't have the same denominator? Okay. In this instance, we have to find the least common denominator. So let's start with this one. Suppose you have x plus 2 over 2x minus 3 plus, let's put it minus. So it is minus 4 over x plus 3. As you can see, the two denominators are not the same, so we have to make them the same. But before we do that, the first step that you would do would be 2x minus 3 is equal to 0, 2x is equal to 3, then x is equal to 3 over 2. So you're going to write x cannot equal to 3 over 2 because the 3 over 2 makes the first rational expression 0, meaning what? Undefined, and x plus 3 and x cannot equal to negative 3. So once we get that out of our way, these two have nothing in common. So if they have nothing in common, just the product of the two would be your least common denominator. So the least common denominator here is 2x minus 3 and x plus 3. Okay. Once you do that, let's rewrite the first expression. X plus 2 over 2x minus 3. What this expression needs is x plus 3 to make it the same denominator. So I'm going to do x plus 3, x plus 3. Okay. Whatever we do for the bottom, we also have to do the same for the top. Minus 4 over x plus 3. This time x plus 3 needs 2x minus 3 and 2x minus 3. I advise you when you do this kind of problems, it's tedious, so take your time. Now we know we have the same denominator. So I'm going to rewrite x plus 3 and 2x minus 3. Okay? I'm going to do a FOIL here. So x times x is x squared, x times 3 is 3x, and then 2 times x is 2x, and 2 times 3 is 6. I'm going to put a parenthesis, minus. Now I'm going to distribute 4 to everything inside, so that would be 8x minus 12. Okay? Now, we're almost done. Now what I'm going to do would be combine like terms for this one. So 3x and 2x, it gives us x squared plus 5x plus 6 minus 8x minus 12 over x plus 3 and 2x minus 3. Right? Now, let's combine them together. You have x squared here. Now 5x minus 8x gives us minus 3x. Right? And 6 minus 12, which is 6 plus 12, which is 18. And so you end up with x plus 3 and 2x minus 3. Okay. Now we are going to use the product and the sum for the trinomial. Two numbers multiplied will give us positive 18, and added will give us negative 3. So, meaning what? We have to have, okay, let's see. But, so that means if we go ahead and do this product, 18 sum is negative 3. We cannot find two factors multiplied will give us positive 18 and that will give us negative 3, because if the product is plus, either both of them have to be positive or both of them have to be negative, right? So you can have negative 18 and negative 1, negative 6 and negative 3, and you can keep on finding all the possible factors, but you will end up with a prime. So you're going to end up writing this x cannot equal to negative 3 and x cannot equal to 3 over 2, and then move down. Okay, just one more. Let me do another one. Suppose we have x plus 3 and x squared plus x minus 2 plus 2 over x squared minus 1. Now we have to deal with factorizing the denominator first. So two numbers, I'm going to write this, x plus 3. Let's ask ourselves, what is two numbers multiplied will give us negative 2 and added will give us positive 1. So it would be x plus 2, x minus 1. Okay. Plus 2. This is the difference of 2 squared. So I can write this as x plus 1 and x minus 1. Now we know the restrictions. X cannot equal to 2, x cannot equal to negative 1, and x cannot equal to 1. Right? So know that. So probably let me write it here. X cannot equal to negative 2, x cannot equal to 1, and x cannot equal to negative 1. Now we are going to make the denominator the same. Look, I have x plus 2 and x minus 1. So what I'm missing for the first denominator is x plus 1. So whatever I do here, I also do x plus 1. If you go to the second rational expression, you have x plus 1 and x minus 1. What you are missing is x plus 2. So you do this. Okay. Now we know we have the same denominator. Okay. So all I need to do is FOIL this. X times x is x squared. X times 1 is x. 3 times x is 3x. And 3 times 1 is 3 for the first one, right? And for the second one, we have 2x plus 4 if I distribute 2 to everything inside. So let me rewrite this. Let's combine the like terms. X plus 3x is 4x. So I'm going to have x squared plus 4x plus 3 plus 2x plus 4 over x plus 2, x minus 1 and x plus 1. Okay. We're almost done. So we can add, if we add, we end up with x squared. 4x plus 2x is 6x, right? And 3 plus 4 is 7 over x plus 2, x minus 1, and x plus 1. Okay? So you end up with this. Two numbers multiplied will give us 7, and added will give us 6. We can't have that, because 7 times 1, the only two factors is 7 times 1 is 7, but the middle term is 6x, so you would end up with this, and your final solution x is equal to. Okay, so that takes care of the rational expression. In the next session, we're going to do complex fractions.